1.5. Section 1.5. Here are our objectives for today. Solve quadratic equations by factoring. Solve quadratic equations by the square root property. Solve quadratic equations by completing the square. Solve quadratic equations using the quadratic formula. Use a discriminant to determine the number and type of solutions, and determine the most efficient method to use when solving a quadratic equation. Okay? So we definitely did all of these in Algebra 2. And we also definitely took about 2 weeks to do all of these. We're doing them in one section. Okay? So first of all, please be patient with yourself as we're going through these, because it's a lot of information. Okay? Be patient with yourself and each other, and we'll get through all of them. Is that fair? So let's start with factoring. Okay? Solving quadratics with factoring. So we'll start off with an equation like this. X squared minus 7x plus 10 equals 0. Okay? So there's a lot of different ways to factor trinomials like this. The way I showed you was we found AC, right? Because ax squared plus bx plus c is the general form for a quadratic. So we found AC. And in this case, AC is what? Well, A is 1 and C is 10. So A times C, 1 times 10 is 10, right? And B is just negative 7. And we said, what two numbers multiply to be AC, but add to be B? So what two numbers multiply to be 10, but add to be negative 7? What do you think? Negative 5 and negative 2, right? Negative 5 times negative 2 is 10. Negative 5 and negative 2 are negative 7, correct? Since the leading coefficient right here is 1, we could do a quick shortcut and go straight to our factors. I'm going to show you what happens if that's not true in just a second, okay? But because the leading coefficient is 1, we can go straight to our factors, x minus 5, x minus 2, okay? There's a rule that says a times b equals 0. If that statement is true, then either a equals 0 or b equals 0 or both. So if this times this equals 0, either this is 0 or this is 0 or both. But so that we don't ever leave any answers off, we just always do both. Does that make sense? So now if I'm solving for x, I just have to add 5 to both sides to get x equals 5. I have to add 2 to both sides to get x equals 2. Does that make sense? To check our work, we could plug them both in. 25 minus 35 is negative 10. Plus 10 is 0. 4 minus 14 is negative 10. Plus 10 equals 0. So they both work for this situation. Does that make sense? Now, if you didn't remember that the whole leading coefficient was one thing, this is what we did before. Okay, I'm doing this exact same problem again because I want to remind you how we did it at the beginning. All right, we still did AC, we still did B. We found that negative 5 and negative 2 worked. What we did before we knew the shortcut was we split the middle term into 2 parts. We said x squared minus 5x minus 2x plus 10 equals 0. So everybody see where I got those 2 middle terms? Okay, and then we factored by grouping. Because there's 4 terms, we can group the first 2 terms, group the second 2 terms. What's common in these 2 terms? What do they both have? An x. If I factor out an x, what's left? X minus 5. Perfect. Look at these 2 terms. What are they both divisible by? What's common? 2, and we're going to in fact take out a negative 2, aren't we? Because I know I need my parentheses to be exactly the same. And if I just took out a 2, it would say negative x plus 5, and those wouldn't be the same, would they? Now looking at this term and this term, what do those two terms have in common? An x minus 5. If I factor out an x minus 5 from each one, what's left? X minus 2. So do you see that we got to the same place? Yes, two different ways. We typically go from here straight to the factors if the leading coefficient is 1. If the leading coefficient is not 1, we have to do it this way. Okay? Any questions with that? Then at this point, we would set both of these equal to 0 and get x equals 5, x equals 2, right? Okay. There's some ways that you need to know how to factor that I'm going to remind you of. We've talked about them before in Algebra 2, but I'm reminding you of them now, yes? The first is the difference of squares. For example, x squared minus 25. How would we factor the difference of squares? It's a super, super quick way. I have two binomials. The square root of the first term goes at the beginning. The square root of the last term goes at the end. And one is a plus and one is a minus. And it's as easy as that. Okay? For the difference of squares. 4y squared minus 49 would be 2y minus 7. Perfect. Right? Now, making sure you understand what this means. What does the difference of squares means? Difference means I'm subtracting. Squares mean it's a number I can take the square root of. Does that make sense? So what about this? What does that mean? Sum of squares. I'm adding, right? I'm adding two terms that I know the square root of. This one's my favorite one to factor. Because you can't. It's prime. I'm done. It can't be factored into other parts because the only thing it's divisible by is itself and 1. That's what makes it prime. Does that make sense? Okay. Then we have difference of cubes. Well, difference, you already know what that means. Right? Subtract. And what does cubes mean? Something that I know the cube root of, right? Do I know the cube root of both of these? What's the cube root of a cubed? A. What's the cube root of b cubed? B. Yeah. So the way we factor this is we get a binomial and a trinomial. A place for 2 terms and a place for 3 terms, right? So we find the binomial first. Remember, I didn't teach you a quote-unquote formula for this. I taught you a pattern, right? Because nobody wants to memorize formulas. We want to remember patterns. That's easier, okay? So I take the cube root of this and the cube root of this and put it in my binomial. Yes? To find the trinomial, I square this. I multiply these two together, and I square this. And remember, there was a pattern to our signs. Whatever sign was in the problem goes in the binomial. The next sign is opposite of that, and the last sign is always plus. Now, all of these that I've done so far, there's a way to check them, right? You just multiply them back out. And if I multiply them back out, I should get the original problem that I had, right? Yeah? So what about sum, of cubes? What about sum of cubes? What does it look like? Same as difference of cubes, but Yeah, with a plus. So 8a cubed plus 1. Are both those cubes that you know? What's the cube root of a cubed? 2a, right? Because what times what equals 8? 2, right? And what's the cube root of 1? 1. So I have a binomial and a trinomial. Now I'm acting like you already know how to do this one, because if you'll remember, it's exactly the same pattern as the difference of cubes, but the signs are a little different, but the pattern is the same, right? So what's the cube root of the first term? 2a, so it goes here. What's the cube root of the last term? So it goes here. I square the first term to get 4a squared. I multiply them together to get the middle term. And I square the last one to get the last term. The pattern of the signs is the same. Whatever was in the problem is in the binomial. The next sign is the opposite of that. And the last sign, always plus. Is this making you remember any of this stuff? Yes. Okay, good. Those are quite a few examples of factoring, but definitely not the be-all, end-all of factoring. Okay, but I just wanted to give you a few examples to start off with before you start your homework. Does that make sense? So let's talk about square root property. Square root property is relatively, I always hesitate to say easy, because if you don't get it the first time, then you feel bad. And I don't want you to feel bad. Okay? But anytime we're solving quadratics by the square root property, we're basically saying we're taking the square root, right? So if we're saying, here, let me draw a line right here and put square root property. So if I say 3x squared minus 15 equals 0, can we solve that quadratic? Well, what do we do first? Correct. If I add 15 to both sides, I get 3x squared equals 15. Next. Divide both sides by 3. Yeah, exactly. So I get x squared equals 5. How do I undo a squared? I square root, right? Now, who is putting this square root sign in the problem? Who just did that? We did, right? If I put the square root sign in the problem, what do I have to remember as part of my answer? Plus or minus, right? If I tell you right now what's the square root of 9, you're going to say 3. And I'm going to be happy. But if I tell you x squared equals 9, you need to tell me that x equals plus or minus 3. Because the first time the square root was in the problem already. It was given to us, right? We put the square root sign in the problem. We have to remember a plus or minus. Do you guys know the square root of 5? Yeah, me neither. Then we just leave it. Does that make sense? Okay. What about if it was like this? X minus 2 squared equals 6. One possibility is that we could distribute this out, because anything squared is it times itself, right? I could distribute that out. But if it's already set up in a squared, how do we undo a squared? Square root. So if I square root both sides like this, on the left-hand side, what do I end up with? X minus 2. Who put the square root sign in the problem? Then what do we have to remember? Plus or minus the square root of 6, because I don't know the square root of 6, right? And I can't simplify the square root of 6 either, can I? Okay? So how do I solve for x? Yeah, exactly. X equals 2 plus or minus the square root of 6. Done. Okay? All right. Completing the square is what's next. Solving quadratics by completing the square. Okay? If we are completing the square, before we actually solve by completing the square, can we remember first how to complete the square? Are you okay with that? Okay. Something's going to happen like this. X squared plus 8x. It's going to look like that. What's it missing? Either an equal to, or it's missing a constant term or something like that, right? So if we're trying to complete the square, we're missing the constant. Okay? The way that I complete the square is I take the x term and I divide it by 2 and I square it. What is 8 divided by 2? 4. And what's 4 squared? 16. I just completed the square. What if it was x squared minus 10x? Take the x term, divide by 2, and square it. Are you sure it's plus 25? Because it's negative 5, right? If it's negative 10, I divide by 2, I get negative 5. What is negative 5 times negative 5? Oh, it is positive 25, right? Will I ever subtract anything here when I'm completing the square? No, because every time I square something, I'm going to get a positive term. Does that make sense? Okay. What about x squared plus 3/5 x? I know, please don't get mad at me. You'll be fine. Well, if I'm dividing this by 2 and squaring it, which is what I'm supposed to do, dividing by 2 is the same thing as multiplying by what? 1/2, right? So it's 3/5 times 1/2. 3/10, right? Now square 3/10. What's 3 squared? What's 10 squared? 100. Are you okay with that? Okay? So this is like the very first step that we'll have to do every time in completing a square. The next step, because what we just created right here is a perfect square trinomial. What we'll have to do next is write its binomial. Its squared binomial. So I need you to remember how to do that, because that's part of the actual completing the square process, right? So here, x squared plus 8x plus 16, we need to take to its binomial. Well, if I were to factor this, what two numbers multiply to be 16 and add to be 8? 4 and 4, right? So it would be x plus 4 times x plus 4, or x plus 4 squared. What if I wanted to take this one to its binomial? What two numbers add to be, or multiply to be 25 and add to be negative 10? Is it always going to be the same thing? It is, right? Because it's going to be either multiplies to be this or adds to be this. The adds to be this part's going to tell us the sign that we need. So x minus 5, right? Okay. Now this one's not as easy to see, so let's look at it a slightly different way, but still get to the same answer. Is that okay? If I said to you what multiplies to be 9 over 100 but adds to be 3 over 5, seriously, you know what I'm saying? But what's the pattern? What's another pattern that we can see to go from here to here? From here to here. So it's either that number square rooted, or it's this number halved, right? We can either take the square root of the last number to get this number right here, or we can half that middle term. Does that make sense? So use that strategy on a problem like this when it's not as easy to see. Probably square root's easier to see on this one, right? Because half of this, well, except half of this we already did, right? What do you get? 3 over 10, right? Square root of 9 is 3. Square root of 100 is 10. But I also know that 3/5 times a half is 3 over 10. So either way, I got the same answer, didn't I? Does that make sense? So now let's do a problem where we actually have to solve by doing this stuff. Solve by completing the square. You okay with that? So it'll look something like this sometimes. X squared minus 6x plus 4 equals 0. Okay? If we do x squared minus 6x plus 4 equals 0, the first thing I need is the 4 out of the way. Because on all these problems up here, I finished the perfect square trinomial, didn't I? I added that constant term. So first thing I want to do is get rid of the 4. I want to move it to the other side of the equation, or at least out of the way, right? So I get x squared minus 6x equals negative 4. What number is going to go into this blank space that I left right here? How did I get these terms right here? I divide it by 2 and then I square it, right? So what's 6 divided by 2? And then squared? Very good. Now if I add 9 right there, I've completely and totally changed the problem and I will never ever be able to get the right answer. Because I only did something to one side of the equation. Exactly. If I add it to here, I have to add it to here. Does that make sense? So on the left-hand side of the equation, I have my perfect square trinomial. I need to take it now to its binomial. What is the binomial of this perfect square trinomial? Perfect. Equals what? 5. Good. How do I undo a square? Square root. What's the square root of the left-hand side of the equation? X minus 3. What is the square root of the right-hand side of the equation? Perfect. Plus or minus the square root of 5. How do I solve for x? Perfect. X equals 3 plus or minus the square root of 5. Any questions so far? We good? Okay, let's do another example of that if that's all right with you. If it's not all right with you, I'm still going to do another example. Okay. This is what this example is going to look like. Now, how is this different than the last example? Yeah, it has a leading coefficient that's not 1. All the stuff we just talked about is super great steps to do if your leading coefficient is 1. If it's not 1, we got to do some extra work. Okay? I have to actually make it 1. How do I go about making it 1? Thanks. Yeah, what's the 9 doing to the x squared to begin with? It's multiplying, so exactly what you said, I'm going to divide it, right? I'm going to divide every term by 9 on both sides so I don't change anything, right? Well, 9x squared divided by 9, that's just x squared, right? Negative 6x over 9 becomes, good. And then negative 4 over 9, negative 4/9, right? Now just remember your steps. I know there's fractions. Please do not freak out. You'll be all right. What do I do first? I got to get rid of that, right? So I add 4/9 to both sides. X squared minus 2/3 x equals 4/9. Well, it goes in the blank right here. How do I get it? Divide this by 2 and square, right? Dividing by 2 is the same thing as multiplying by what? 1/2. So I end up with 2 over 6, but I can simplify that, can't I? And just get 1 over 3. And then when I square it, what do I get when I square 1 over 3? What's 1 squared? 1. And what's 3 squared? 9. If I add it to this side, I add it to this side. Okay so far? Okay. Now where do I go for my trinomial? Where do I go for my trinomial? Yeah, to your binomial, right? What's the binomial of this one? X minus, because that's the sign of the middle term, right? I can either take half of this or the square root of this. So 1 over 3. Square root of 1 is 1. Square root of 9 is 3. Equals what? 4/9 plus 1/9? Perfect. 5/9. How do I undo a squared? Square root. Square root. Left-hand side? Perfect. X minus 1/3. Right-hand side? Plus or minus the square root of 5/9. Are we allowed to have radicals in the denominator? No, and that's what I have right now, right? So I can't have that. So I'm just going to come over here to the side real quick, if that's all right, and figure this out. Isn't that the same thing as that? Well, do I know the square root of 5? No. Do I know the square root of 9? So this is really plus or minus the square root of 5 over 3, right? This thing right here is really the same as plus or minus the square root of 5 over 3. You okay with that? So when I add 1/3 to both sides to actually solve for x, x is going to equal 1/3 plus or minus the square root of 5 over 3. Now, I do not remember if the computer likes this answer or if it likes another answer better. Because, like, remember when we were working on that problem yesterday, right? So I want to make sure you understand what the other answer is that it likes. Okay? This has a common denominator, so I can actually add the numerators, can't I? And get 1 plus or minus the square root of 5 all over 3. Do you see that those two are the same thing? Yeah? How do you feel about the first 3 objectives on this list so far? Okay? Tell me, before we even start examples, how do you feel about quadratic formula? This is like one of the favorite things that you did, right? Because you're already singing the song right now, aren't you? Okay? You loved it. I know. You sing it every single day. Okay? So, most people like quadratic formula because they know that it works every time. You also know that it's not always the easiest, but you know it works every time, right? And I think that's why people like quadratic formula so much. Okay? So let's remember what it is. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Yes? Let's do one example of it. I know you probably don't need it, but let's do it so it's in the notes for us. Okay? So if we do 8x squared plus 2x minus 1 equals 0. In order to be able to do the quadratic formula, what do I have to have defined for me? A, B, and C, right? What is A in this problem? Because we know, again, like we talked about earlier, it's ax squared plus bx plus c, right? So in this problem, A is 8, B is, and C is -1. Now, sometimes we even like to write it out. We don't always have to write it out, but especially if we're not feeling very confident, we want to go ahead and write that out. So that when I substitute it into the formula to solve it, I have it really clear for myself, yes? X equals -b plus or minus the square root b squared minus 4ac all over 2a. Now it's just a matter of simplifying, isn't it? Okay. I'm going to start inside here because that's a little easier, right? What's 2 squared? That's 4. What's 4 times 8 times negative 1? Well, 4 times 8 is 32 times negative 1 is negative 32, right? So what's 4 minus a negative 32? Isn't that 36? So isn't that the square root of 36? So what I've simplified it to is x equals negative 2 plus or minus the square root of 36 over 16. Now you know and I know that we can go further than that, can't we? Because why? Yeah, we know the square root of 36, don't we? What is the square root of 36? So negative 2 plus or minus 6 over 16. Can we go further than that? Well, what's negative 2 plus 6? 4. What's 4 divided by 16? 4 over 16, which is a fourth, right? What's negative 2 minus 16? Can I say the right word? Negative 2 minus 6. Negative 8 divided by 16? Negative 1/2. Perfect. Thank you. Everybody okay? So these are my two solutions, right? I have two solutions on this problem. Sometimes when I do this, I'm going to get something that looks like negative 2 plus or minus the square root of 6 over 16. Can I go any further there? Not unless it tells me it wants a decimal approximation, right? Otherwise, that's perfectly fine. Sometimes I might get negative 2 plus or minus the square root of negative 6 over 16. If it's the square root of negative 6, I got to pull out an I, don't I? Like we talked about earlier. All of those are okay. Sometimes you'll get answers like this. Sometimes you won't. Sometimes it'll still be as a fraction. You okay with that? The last thing it asks me to do, second to last thing it asks me to do, is to use the discriminant to determine the number and types of solutions. Okay? Well, do you remember what the discriminant is, first of all? The discriminant is right here. The discriminant is just b squared minus 4ac. Okay? Discriminant can tell you some interesting things. First of all, if the discriminant is positive, it's telling you there are two real solutions. If we look back at this problem, my discriminant was 36. 36 is a positive number. I should have two real solutions. And look what I got. Two real solutions. If I graph that, it will either look something like this or something like this. But either way, do you see that it's crossing the x-axis in two places? Does that make sense? If my discriminant is negative, it's telling me I have two imaginary solutions. And if I graph it, it would look something like this. Because it does not cross the x-axis at all. Okay? This is when I would have i's in my answer, right? Square roots of negative numbers. Okay? What's the other choice? It's either positive, negative, or 0. If it's 0, there's one real solution. But I need you to understand it's a double root. It's called a double root. Because what it looks like when you graph it is this or this. It touches the axis at one place, right at its vertex. And it's called a double root because it ends up, instead of like this, you're going to end up with 1/4 and 1/4. There's only one real solution because 1/4 is the same number, but it's 2 times. Does that make sense? Any questions about discriminants? All right, so the last objective that we have today for section 1.5 is to determine the most efficient method to use when solving a quadratic equation. Okay? So think back to the examples that we've done today. I've got them right here on the side beside me, actually below this stack of papers. So we might refer back to them if we need to. You guys have your notes in front of you. When do you think factoring would be the best course of action to solve a quadratic? Well, might I suggest to you that you should factor it if it's factorable? Right? I don't know if that's a real word, but we're going to pretend that it is. Okay? If it's factorable, then factor it. If it's not factorable, don't try to factor it. Choose another way. Okay? If you're trying to do factoring with a trinomial, and we're saying what multiplies to be this and adds to be this, and you can't figure out 2 numbers that work there, don't factor it. Try something else. Okay? When should we do completing the square? Well, I have to tell you, most of the time people won't choose completing the square on their own. Most of the time they'll do completing the square if it tells them to do completing the square, to be honest with you. Okay? So we definitely want to try completing the square if the leading coefficient is 1. Okay? If the leading coefficient is 1, if the leading coefficient is something else, I definitely don't want to try completing the square. Unless it tells me that's how I have to do it. Yeah? What about square roots? When should I try solving with square roots? Here was the examples that I did for you. When there's something that's squared, either just the x by itself, or just the x squared by itself, like in this problem, or something's already actually squared, like in this problem. So when something is squared, because then we can undo it by square rooting it, can't we? And when should we do quadratic formula? Well, when you don't know what to do is a perfect answer. And just remember, it will always work. Okay? It'll always work. So do quadratic formula when you don't know what else to do, and just remember that it will always work. Okay? What questions do you have about these objectives today? Pretty confident? Good, that makes me happy. But if you have questions, yeah, just ask, right?